Hello and welcome to this quite applied electropotentials data question in the long answer style. There's quite a lot going on in it, so let's just dive in and have a look. So it gives you some electropotentials data, and they say the student concludes that different ions containing chromium can act as oxidizing or reducing agents, and using the terms oxidizing agent and reducing agent and ideas about electropotentials and equilibrium, explain how the student is correct. And they want you to include overall equations. So let's think about what the question wants us to do. So firstly, you need to make sure that the words oxidizing agent and reducing agent are correctly used in the answer somewhere. Secondly, oxidizing agent will be found on the left-hand side of one of the equations, and reducing agent will be found on the right-hand side. So you look for chromium-containing species that are on the right and the left, for example, like there. So we're clearly going to be using the middle equation, but when it's acting as an oxidizing agent, it's going to proceed from left to right. When it's acting as a reducing agent, it's going to proceed from right to left. So you need to use electropotential in there to make the decision as to which way round that's going to go. So that would be covered by mentioning more negative or more positive when comparing pairs of redox systems. And then equilibrium would be dealt with by working out which redox system has the position of equilibrium shifting left and which would have it shifting right. So having a look at the actual data, you can see straight away that Cr3 plus would be acting as a reducing agent if the position of equilibrium shifts left. So to make that happen, you have to make sure that the electropotential value, which is plus 1.33 volts, was more negative than the other redox system you pair it up with. So looking at the two redox systems, you can see that there's one redox system that has plus 2.20 volts. So that must mean you need to react Cr3 plus with FeO4 2-. Looking at Cr2O7 2-, if this is acting as an oxidizing agent, the position of equilibrium would have to be shifting right. For that to happen, you need to look for a redox system that has a more negative electropotential. So this will be the one at the top. So in other words, the electropotential of the chromium-containing redox system would be more positive than the other one. So you have to react Cr2O7 2- with C2H5OH. Now you've come across, hopefully, dichromate in acidified conditions being used as an oxidizing agent with alcohols, and obviously C2H5OH is an alcohol. So this connects in a way with another part of the A-level syllabus, doesn't it? So let's take all that and start thinking about how we're going to construct our answer. So zooming in on what the question actually requires, let's think about identifying the chromium-containing ions as an oxidizing agent and the chromium-containing ions as a reducing agent, and think about what we've just discussed and putting it together. Now, to actually put it into words, I actually think it's quite useful to number the redox systems. So instead of saying redox system containing Cr2O7 2- and 2Cr3 plus, you could just say redox system 2, and the examiner will know what you're talking about, provided, of course, you've actually put the numbers in here. So the electropotential value for redox system 2 is more positive than that of redox system 1. The position of equilibrium redox system 2 shifts right, and the position of equilibrium redox system 1 shifts left. So you need to say what's acting as an oxidizing agent and what's acting as a reducing agent. Doing the same for 2 and 3, you can say something similar. Now obviously it says to include overall equations, and I'm out of space, so what I'm going to do now is scrub a bit of the writing at the bottom and replace it with the equations. Obviously the writing at the bottom goes into your answer, but we now need to focus on the equations. So if you combine redox systems 1 and 2, I've highlighted the things that need to be cancelled. So 14H plus and 6H plus will cancel out, leaving 8H plus at the bottom. The 6E minus will cancel out completely. Now, the equation at the top needs to be multiplied by 3 to balance the electrons, because you can see quite clearly that you've got 2 electrons here and 6 electrons here. So this needs to be multiplied by 3 throughout. So combining those two gives you this as the overall equation. Doing the same for the chromium-containing ions as a reducing agent, this time we're going back to redox systems 2 and 3. Again, you need to do a bit of multiplication and cancelling. So 7 and 8 waters cancel out, don't they, to leave 1 H2O down here, and this will disappear. 16 and 14 cancel to leave 12 down here and none up here, and the electrons cancel out completely. And you need to multiply the equation at the bottom by 2 to balance the electrons, because this time you've got 3 electrons and 6, so therefore these need to be balanced out. So we multiply this one up. And that gives us this equation. So let's have a quick check of the mark scheme. So that's what they want. You've got actually 6 marking points if you count them up, but only 5 marks. 1, 2, 3, 4, 5, 6. So what you'll need to do is make sure that your answer has a good spread of marks across all of these ideas. Now, as a general rule, you can always assume that the reverse argument can be applied throughout. And we can use an equilibrium sign, a reversible sign, instead of an arrow going from left to right. But generally, we will write it as an arrow going from left to right, because by this time we've worked out which direction the position of equilibrium has shifted. Now, one point that's worth mentioning is looking for cons. So a con is a contradiction between the or statements. So here's the or statements down here and up here. So what they mean really is if you say two things about the same aspect of a reaction, but one contradicts the other, the mark is lost, because overall you're not really making sense, even if one of your statements is correct. It's a bit like in a multiple choice question saying, well, the answer is going to be A, B, C, or D. Well, of course it is. You need to decide which one to choose. Okay, so hopefully this has been a useful look at what's actually quite a difficult question, and it gives you a way to navigate the mark scheme as well. So until next time, thanks for listening, and see you soon.